Today we will review our order of operations. We use order of operations when we encounter an equation that has multiple operations. The correct order of operations must be done in order to get the correct solution. To help us remember the correct order of operations, we have an abbreviation called PEMDAS, where the P stands for parentheses, E for exponents, M for multiplication, and D for division. Then finally A for addition, and S for subtraction, where parentheses are always dealt with first, and addition and subtraction are always handled lastly. Multiplication and division have the same rank and can be done in any order, as well as addition and subtraction, which have the same rank, but are done last. Down below we have an equation that we have to solve by using the correct orders of operations. So our first order of operations is to deal with the values inside the parentheses. So if we deal with the values inside the parentheses, we have 4 plus 2, which equals 6, to the second power, minus 4, subtract 8 divided by 2, which will give us 4, to the 6th power, times 2. If we deal with our exponents, we'll have 5 minus 6 to the second power, which will give us 36, minus 4 minus 4 will give us 0 to the 6th power, which will be 0 times 2. Now that we have dealt with our parentheses and exponents, we can deal with the multiplication. The only multiplication we have is 0 times 2, which will give us 0. So we're left with 5 minus 36 minus 0. Now we can subtract our last remaining values to get the correct solution of 31. Now that we know the correct order of operations, we can simplify algebraic expressions by combining like terms. When combining terms, we can only add and subtract terms that are alike. Let's apply this rule to the following examples below. So for problem 1, if we look inside the parentheses, we have 9n minus 9. Since these terms are not alike, we can't simplify the values inside the parentheses. So instead, let's start by distributing our negative 5 through the parentheses. So if we do so, we'll have 10 minus our negative 5 times 9 will give us a negative 45n. And then if we take negative 5 times negative 9, it'll give us a positive value of 45. Now we can add our 10 plus our 45 will give us 55 minus 45n, which is the simplest expression we can get. In our second example, we'll do the same thing. We'll distribute our numbers through the parentheses to get one complete expression. 5 times negative 2n will give us negative 10n plus 5 times 4 gives 20 plus 2 times n gives 2n plus 2 times 3 will give us 6. We can combine negative 10n and 2n by adding them together, which will give us a value of 8n plus adding 20 plus 6 will give us 26. So our overall expression will be negative 8n plus 26. Lastly, in our last example, if we distribute our values through parentheses, we'll get negative 30b minus 30 plus 5b plus 10. If we add negative 30b plus 5b, we'll get negative 25b. And if we add negative 30 plus 10, we'll get negative 20. So our simplified algebraic expression would be negative 25b minus 20.